desktop mouse and keyboard controls. And again, we are continuing with this game example, and let's give it a try again. So let's check it out. So I can move backwards, forward. Okay, let me see. X. Okay. Keyboard. Trying to avoid this with the keyboards up and down. Trying also to move forward with the right and keyboard, left keyboard. So okay, if I press the continue. Okay, so I think I'm doing good. Let me see. Oh no. yeah, that was pretty cool. Okay, so let's continue. Now, when we have our mobile controls in place and the game is playable on touch enabled devices, it would be good to add mouse and keyboard support so the game can be playable on desktop also. Okay, so in desktop, like this computer, like this laptop that I'm using right now. That way we can broaden the list of supported platforms. We will look at this below. So it's also easier to test control independent features like gameplay on desktop if you develop there. So you don't have to push the files to a mobile device every time you make a change in the source code. So here we have note. The Captain Rogers battle at Andromeda is built with Phaser, and managing the controls is Phaser based, but it could also be done in pure JavaScript. The good thing about using Phaser is that it offers helper variables and functions for easier and faster development, but it's totally up to you which approach you choose. So pure JavaScript approach. Let's think about implementing pure JavaScript keyboard mouse controls in the game first. To see how it would work, first we need an event listener to listen for the press keys. So again, this is just the theory. So what we would do is document that at event listeners, and we would pass the string key down as well as the variable, the parameter key down handler and the boolean false, and then we will have a second line of code that is the document that at event listener we are passing the string key up, the parameter key up handler, and finally the boolean false. Whenever any key is pressed down, we are executing the key down handler function, and when press finishes, we are executing the key up handler function, so we know when it's no longer pressed. To do that, we will hold the information on whether the keys we were interested in are pressed or not. So right now we will have some variables. So we have the let statement declaration, and we have the variable right pressed, and we are setting it to the boolean false. We have the let left press, we are setting it to the boolean false. We have the let up press, and we are setting it to the boolean false. And finally the let down press, and again setting it to the boolean false. Then we will listen for the key down and key up events and act accordingly in both handler functions. Inside them we can get the code of the key that was pressed from the key code property of the event object, see which key it is, and then set the proper variable. There are no helpers, so you have to remember that the given codes are on the look them up. 37 is the left arrow. So, and again, all the code is in the GitHub repository. Let me see. Now here we will have a function, so we have the function key handler, so we're passing the event, and inside of the curly braces we will have the if statement declaration. So we have a statement here: if the event.key code is equal to 39, then we're gonna do something. So pretty much we are gonna set the right pressed, we're gonna set it to true, to the boolean true. Else, so if the event.key code is equal to 37, the left press is assigned to the boolean true. Okay, so we close the curly braces of the else if statement, to the else if statement. We will have a second if statement. So if the event that key code is equal to 40, then we are gonna have the down press set to true. Else if the event that key code is set to 38, we will have the up press set to true. So this is pretty much the code here. The key up handler looks almost exactly the same as the key down handler above, but instead of setting the press variables to true, we will set them to false if the left arrow is pressed. So if the left arrow is pressed, the key code 37, we can set the left press variable to true, and in the draw function perform the action assigned to it. So move the ship left. Okay, and here is pretty much the function draw. So we have the function named draw, and inside of the curly braces, okay, and we already saw this in a previous video, we will have the ctx, and we will use the method clear react. So we have the ctx that clear react, and we will pass in the parameter 0 0, canvas that width, and finally the canvas that height. So these will be the parameters, and then we will have an if statement declaration. So if the right press, then we're gonna have the player x, we are setting it to the plus equal sign 5. So this is pretty much saying that the player x is gonna be set to the player x plus 5. Else if the left press, so if we are pressing the left keyboard in our laptop or computer, then the player x is gonna be set to the minus equal sign 5. So it'll be the player x is gonna be set to the player x minus 5. So we have that. Okay, so now we're gonna have a second if statement. So if down press, we are gonna have the player y plus equal sign 5. Else if up press, we're gonna have the player y set to minus equal sign to 5. Okay, then we will have this variable, the ctx, and we are gonna use the draw image method, and we are gonna pass in the image the player x and the player y. Close out with a semicolon, and finally we will have the request animation frame, and passing in the name of our function, that is this one, draw. So this is the theory how we would do it. The draw function first clears the whole canvas. We draw everything from scratch on every single frame. Then the press key variables are checked, and the player x and player y variables that we defined earlier just after left press, and the others holding the position of the ship are adjusted by a given amount, let's say 5 pixels. Then the player ship is drawn on the screen, and the next draw is called from within the request animation frame. We could write that our own key code object containing the key codes, for example, and this is how we would do. We have the constant statement, the constant declaration, and the name of this variable would be keyboard helper, and we would set it to this object with key value pair. So we have the left, this is the key, and the value with 37. Then we have the second key value pair. Up is the key, and 38 the value, and right would be the key, 39 the value, down would be the key, 40 the value. Okay, that way instead of using the codes to compare the input and the handler functions, we could do something like this, which is arguably easier to remember. So here we have the left press is gonna be assigned to the event that key code that is equal to the keyboard helper that left. So we have that. Note you can also find a list of the different key codes and what keys they relate in the key code reference page. So this is pretty much the image that are showing us. So in this project, and this, let me see if I open it here with HTML, we are not gonna have the whole game, but it's just gonna be pretty much, we have the spaceship, but we are able to maneuver it, so we're able to go in the y coordinates and the x coordinates. So we have that, we can move it around, we cannot shoot, but we can pretty much maneuver around here with keyboards as well as with the mouse. Okay, oops, that's the game. Let me see. So you can see the example, so you can click here and get the code example. So the phaser approach. Okay, so now we're gonna see the phaser approach. As mentioned before, you can write everything on your own, but you can also take advantage of built-in functions and frameworks like phaser. This will make your life easier and development a lot faster. All the edge case differences between browser implementations, etc., are handled by the framework, so you can focus on the actual tasks you want to do. So the mouse interactions in the game are focused on clicking the buttons, and phaser, the buttons you create will take any type of input, whether it's a touch on mobile or click on desktop. That way, if you already implemented the buttons as shown in the mobile touch controls article, it will work out of the box on the desktop too. So here they give us this example, that is the constant declaration name button enclave. We already saw this, and we are setting it to the des.add button. We are setting it to the des.add that button, and we are passing parameters. So the number 10, again the number 10, the string logo dash enclave. We have the keyword des.click enclave, and finally the keyword des. So we have that. The button will be placed 10 pixels from the top left corner of the screen. Use the logo enclave image and will execute the click enclave function when click. We can assign actions directly to the button. So we will have the keyword des.button should, and we are setting it to the des.add button, and we would pass in the des.world width multiplied by 0.5. Then we would pass the second parameter, just 0. The third would be the string button dash alpha. The fourth would be null, and the fifth would be the keyword des. So we have that. Then we will have the des.button should that on input down that add, and we would pass in the des.should impress, and as a second parameter the keyword des. Finally, we will have the des.button should that on input up that add des.shooting release, and then the keyword des. The button used for shooting works perfectly fine on both the mobile and desktop approach. If you want to use the mouse's cursor position on the screen, you can do that with the des.game.input.mouse pointer. Let's assume you like to shoot a bullet when the right half of the screen is clicked with a mouse. It would be done something like this. So if des.game.input.mouse pointer that is down, then we'll have a second if statement inside of the first one. So if des.game.input.mouse pointer that x is greater than the des.world width multiplied by 0.5, then we will have the code here, the body code, so pretty much the shoot. If you like to differentiate the mouse buttons being pressed, there are 3 defaults you can pick from. So we have the des.game.input.mouse pointer, and we have the left button is down. Then we have the same thing, but we have that middle button is down, and finally that right button is down. Keep in mind that instead of mouse pointer, it's better to use active pointer for platform independent input if you want to keep the support for mobile touch interactions. Keyboard: the whole game can be controlled with just the keyboard and nothing else. The built-in des.game.input.keyboard object manages the input from the keyboard and has a few helpful methods like add key and s down. There's also the phaser.keycode object, which contains all of the available keyboards key, and here we have it. So they are giving us this example. So you have the .a, .alt, backspace, and you can check out the space bar. So for this game, for this game, in order to shoot, I'm using the what it was, the space bar. Okay, so In the main menu of the game, we can add an extra way to begin playing. The start button can be clicked to do so, but we can use the enter key to do the same. So we will have the constant declaration name key enter, and we're setting it to the desk again that input a keyboard that add key, and we're passing the phaser the key code that enter. Okay, so we end this statement, then we have the key enter that on down that add, and we would pass into parameters desk that click start in the keyboard desk. You can use the add key to add any key the phaser key code object has to offer. The undown function is executed whenever the enter key is pressed, and we launch the click start method, which starts a new game. So it's useful to provide an option to play the game on desktop without using a mouse, so you don't have to take your hands off the keyboard.